Algebra I, Rational Expressions number 10.4, Addition and Subtraction with like denominators. To add or subtract rational expressions with like denominators, we add or subtract the numerators and write the sum or difference over the common denominator. So take a look at these fractions. If we're going to add 5/7 plus 3/7, they have a common denominator. We just add the numerator. We get 8/7, don't we? And if we're going to add it over a variable, we have 5 over x plus 3 over x. We just get 8 over x. See? We just slide that denominator over. For subtraction with like denominators, we just slide that denominator over and subtract the numerators. So 9/5 minus 3/5 would be 6/5. We could simplify that to 1 1/5 too if we wanted to, couldn't we? 9 over a minus 3 over a. We subtract the numerators and we get 6 over a. Take a look at this one. Now we've got x over z plus y over z. Well, because these are different variables, we end up with just x plus y over z. And for subtraction, if we've got a over c minus b over c, it simplifies to a minus b over c, because these are different, aren't they? We can't combine them. In a case like this, where we have 3y plus 2 over 3y squared, and we're adding it to 4y minus 1 over 3y squared, it's got the same denominator. We just slide that denominator over, and we add these together. So we've got 3y plus 2 plus 4y minus 1. We combine the like terms. We got a 3y and a 4y. That makes 7y. And if we have a positive 2 and we take away 1, we have a positive 1, don't we? We put that over our common denominator, 3y squared, and that's our simplified answer. See? And sometimes we're going to have to factor, all right? Sometimes we can cancel out. So now we've got 3x over x plus 1, and we're adding it to 3 over x plus 1. We've got the same denominator. We just slide that over, and we end up with 3x plus 3 over x plus 1. We can factor this as 3x plus 1. See? That makes 3x plus 3. See? So now we've got an x plus 1 over an x plus 1, don't we? See? And we can cancel these out. And the only thing that's left is the 3. It would be a 3 over a 1, wouldn't it? Which would be a 3 when it's simplified. Let's take a look at this one. We've got 4a over 3 plus 5a over 3. We've got the same denominator, so we just slide him over. And 4a plus 5a makes 9a. When we simplify this, 9 over 3 is a 3. We end up with 3a. See? Take a look at this one. We've got 6x squared over x plus 2, and we're adding it to 4x squared over x plus 2. We've got the same denominator, so we just slide him over. Write our big fraction bar, and we make our addition problem, 6x squared plus 4x squared. They've got the same variable and exponent, don't they? So we just end up with 6 plus 4, which is 10, x squared, and that's going to be over the x plus 2. See? And that's simplified as far as it can go, all right? Just remember, a fraction is simplified if the numerator and denominator have a greatest common factor of 1, all right? Take a look at this one. We've got this big trinomial over this binomial, and we're adding it to this trinomial over the same binomial. So it's got the same denominator. We have to put all of this together and add it all together, okay? So we've got our 2a squared plus 3a minus 7 plus a squared plus a minus 8. We can combine these like terms. We can put the pink ones together. 2a squared and a squared makes 3a squared. We're going to add a positive 3a and another positive a. That makes 4a. Then we get a negative 7 and a negative 8. That makes negative 15. So now we've got this trinomial over this binomial. So we have to factor this one out first before we can cancel, right? So if you remember how to factor trinomials, we end up with a plus 3 times 3a minus 5 when this is factored, okay? And if you don't remember factoring of trinomials, I've got a link to my factoring polynomials playlist in this description that you could do a real quick review, okay? Because you're not going to be able to keep going forward in learning unless you remember how to do this, all right? So now we've got this as our numerator over the 2a plus 1, and there's nothing to cancel out because it doesn't have any common factors. So we're done. This is as far as we can go. See? It's pretty big for being finished, isn't it? But that happens sometimes. All right, so that was adding with like denominators. Now let's try subtracting and simplifying, okay? So now we've got 3x over x plus 2, and we're going to take away x minus 4 over x plus 2. We have the same denominator, all right? So we're going to slide that over here, put our big fraction bar, and we've got 3x minus x minus 4, and we need parentheses around this x minus 4 because we have to subtract the entire numerator as a single quantity, all right? What happens is we distribute this negative sign, and it makes this a positive. See that? Got to do that, all right? Got to do the parentheses and then got to distribute that negative sign, all right? So now we've got 3x minus x plus 4 over x plus 2. We combine the like terms. 3x minus x makes 2x. We put our plus 4. Now we can factor this. We have to factor it first before we can cancel out. So 2x plus 4 becomes 2 times x plus 2. See? 2x and 2 times 2 is 4. It's the same thing. So now we've got 2 times x plus 2 over x plus 2. We can cancel these out, and when it's simplified, we end up with just 2 over 1, which is 2. See? All right? The most important thing you have to remember is the parentheses and distributing that negative sign. That's where a lot of mistakes happen, okay? Let's take a look at it doing it again, all right? In this one, we had a x minus 4 up here, all right? Let's see what happens when we have a plus, okay? So now we've got 2a over a minus 1, and we're taking away a plus 3 over a minus 1. We have the same denominator, so we just slide him over, put our big fraction bar, and we've got 2a minus, and put parentheses around the a plus 3, okay? Got to use the parentheses when we have that subtraction sign, okay? So now we can distribute this negative sign, and it makes a negative 3. See that? Now we can combine like terms. 2a minus a makes 1a. We don't have to write that invisible 1, do we? We just write an a. So now we've got a minus 3. When we combined these, we ended up with just a. All right? So now we've got a minus 3 over a minus 1. And that's as far as we can go. It's simplified. Greatest common factor would be 1 for those. So just remember to use parentheses after the subtraction sign and to distribute it, okay? Parentheses and then distribute that negative when we're subtracting and simplifying, okay? Our next video, 10.5, we're going to do addition and subtraction of rational expressions with unlike denominators, all right? And if you want to get a chance to review factoring polynomials, the playlist is in this description. You can just click on it. And if you want to see how to multiply or divide rational expressions, which we just did in 10.2 and 10.3, that'll be in there, along with the simplifying one that we did in 10.2, 10.1, okay? All right, so let's continue on to 10.5, and we'll talk about unlike denominators. I hope you're doing okay. If you found this really confusing, try watching it a second time. It might help, okay? I'll see you. Bye.